Hello guys, in today's video we'll be looking at CP or the critical point. It's also called the point of equal time, PET, and also it's called the equitime point, ETP. Now what is this critical point? It is the point in the journey of an aircraft from which it takes equal time to go to a destination or come back to the place of departure. So basically, at the critical point, you have the decision to go either back to your origin airport or to your destination airport. The time taken will be same. Now why is this important? In case of an emergency, in case of sudden medical emergencies or whatever it be, the critical point gives a quantifiable distance up to which it is sensible to return to your departure airport rather than proceeding to your destination airport. Now the formula for critical point is: consider two aerodromes A and B, and the distance between the two aerodromes is D. The critical point is present here. Then the distance to this critical point equals dH divided by O plus H, where O and H are the outbound ground speed in knots and the inbound ground speed in knots. Now the time taken to reach CP will be the distance to CP divided by the ground speed out, the outbound ground speed. Now the critical point will vary according to whether all your engines are operative or not. That is, it depends on your ground speed. So distance to CP could be calculated using the reduced ground speed if an engine is having failure, but the time to CP is usually calculated using the normal ground speed. Now there are certain points to note. The first one is this critical point is deeply influenced by the presence of winds. A rule of thumb is CP will move into the wind. Now if we look at this example, if we have a headwind component, the CP will shift more towards the wind. That is, it moves towards the wind. So it will be somewhere around here. If we have a tailwind component, it will move nearer to the wind. So it will be around here. If there is no wind present, the CP will be exactly in between A and B. Now distance to CP will be equal if what I just said now, no wind is present, or the second case is if beam winds are present. Now what are beam winds? If this is our track and the wind blows at 90 degrees to our track, this is called a beam wind. The last point I would like to emphasize about the critical point is the critical point is independent of fuel. It does not matter how much fuel you have on board or what is the flight fuel. CP is totally independent of fuel. Rather, it is governed by the ground speed. So keep that in mind while doing the questions. Another point to be noted is if a headwind component changes to tailwind component or vice versa, distance to CP also changes by the same distance from halfway. For headwind component of 50 knots, calculated DCP is 750 nautical miles for the total route distance of 1200 nautical miles. Now in actual flight wind component is found to be 50 knots of tailwind. The new position of DCP will be. Now what happened is they calculated the distance to CP as 750 nautical miles, but in actual flight the wind component is found to be 50 knots of tailwind, so the winds gets reversed. The headwind becomes tailwind. Now we know half of 1200 will be 600, and 750 nautical miles is 150 nautical miles more than 600. So this is for headwind. Now since the magnitude of the wind is same, and what happened is just the headwind turned into tailwind, so we can by this relation we can say that the new position of the CP, or the critical point, will be 600 minus 150, which equals 450. So the correct answer is B. Also, for the same headwind, if the true airspeed reduces, DCP will increase.